Momentum is a vector quantity. Momentum was defined as mass times velocity. Out of the two, mass is a scalar, but velocity is a vector. And when you multiply a vector by a scalar, you still get a vector quantity. Basically, if you have an arrow and you multiply, that arrow by a scalar, you get an arrow pointing in the same direction. That would be just its length would be changed according to what scalar you're multiplying it by. So when we're doing calculations with momentum, and as a preview or important idea that we need to know for to talk about the law of conservation of momentum is the idea that momentum is a vector, and we have to treat it as such in our calculations. So as an example, here I have a ball having a mass m, and the ball is rolling toward the wall to the right. So I guess here's the wall, here's the ball. The velocity of the ball is 3 meters per second in the direction showed by the arrow. After the ball hits the wall, it is going to spring back, and it is going to be moving at the velocity of 3 meters per second in the opposite direction. So if we were to treat velocity as a vector, then if this was positive 3 meters per second, this would have to be negative 3 meters per second. As far as momentum then, the momentum when the ball was moving toward the wall, it will be given by the product of mass times velocity, so 3 times m. In the second case, in the case when the ball is moving away from the wall, the momentum now would be negative 3, that's for the speed, for the velocity, times the mass, so negative 3m. So then when we are talking about the change in momentum, which you remember is important from the momentum impulse theorem. When we talk about change in momentum, the change in momentum of the system would be the final momentum minus the initial momentum. Now when you plug those values in, you see that they don't actually subtract. Well, they do subtract, but they subtract, or they add as two negative values. So the change in momentum is actually equal to negative 6m, not 0, but negative 6, or 6 times the mass, the quantity 6 times the mass, in the direction given by the negative sign, so in that direction. And that actually tells you also in which direction was the external force applied. If that's the negative direction, and the change in momentum was negative 6m, then you know that the force was applied in that direction.